Okay. Good afternoon, all. Right. So today we want to start our next topic, that is databases. Okay. Right. So far we have done 7 topics. Right. 7 topic out of 17, including the big topics like uh, networking, system analysis, and design. So now we have 3 more big topic, that is database, programming, web development. So once these 3 topics are done, it's pretty much like end of the syllabus, because other 3 topics are pretty much very small topics. Okay, and just 2 weeks per topic. Right. So let's move on to our new topic, a database management system. Remember when we did system analysis and design, I mentioned you that. So the more details about data related analysis and design will be covered in the database management system. And also a little bit more details about designing, structured designing will be covered in programming. Okay. So now we move on to the database management system. So I will show you the syllabus first, overview, introduction to DBMS, or introduction to database management system, data analysis and ER modeling, database design, normalization of data, and finally you have the SQL. Okay. And every year you get 1 second paper part B question, full question from this topic, and also plenty of MCQs. And some years there are questions in the structured paper as well. Sometimes MCQ structured question or part of the structured question plus second paper part B. Always second paper part B question is there. Okay. So therefore, this is one of the most important topic for your exams as well. Right. So I will show you the syllabus also. So this is your topic number 8, databases. So you have data versus information, structured versus unstructured data, definition of database, database models like flat, hierarchical, network, relational, object relational, and comparison of the data models. So then you have some other topics. So today we cover this one. And also we want to move on to another part of your syllabus, that is ER diagrams and extended ER diagrams. Okay, so let's see whether we can move on to this part, but definitely we want to finish this part, introduction to database management system. Okay, right. So again, the note is available in the Google Classroom under databases, introduction to DBMS. So this is the note that I will be referring today's session. Maybe we can move on to the data analysis and ER modeling as well. Okay, right. So let's move on to this, the first part, introduction to database management system. Okay. Right. So this is not a difficult topic. Only thing is you need to understand the concept. Right. It's actually a small topic if you understand the concepts. Okay. Right. So we'll cover what is a database management system, bit of introduction, then data analysis and modeling, then database design, ER modeling and normalization, and SQL, and a little bit of security. Okay. So that is the idea. Right. So why do we need database management or database management system? So the reason is, remember, information technology is all about process your data into results or information. So therefore, obviously, we need a way to save data, and sometimes even save information. So there's a little bit of fuzzy margin between data and information, because after some time, after you process a little bit, it's information. Okay. So therefore, we need a way to store data, or sometimes even to store information. Okay. So that is why you need database management systems. Okay. So keep data related to important entities. If it is a business, maybe about your customer data, your product data, your order data, payments data. And also you need to keep track of the transactions, right? Like accounting system. Sometimes those are regulatory. And also you need data for better decision making, planning, especially for managers. Remember, we discussed about MISs, DSSs, executive information systems. So all those info systems rely on data to provide reports and so on. And also business analytic data mining these days, there's a lot of demand for data scientists. Okay. So there are even degree programs on data science with artificial intelligence and so on. So therefore, data is important. First of all, we need to keep track of data related transactions, and then we need data for better decision making, planning, marketing, and so on. Okay. Right. So what are the tasks in managing data? Obviously, we need to save data so that later we can access it. And sometimes we need to update and delete data. Maybe the customer's contact number is updated. Students' payments must be updated. Maybe we want to delete that data. No longer we have that customer. No longer we are interested in that particular order. And also we need to retrieve data. Okay. Persist or save, update, delete, retrieve. Okay. In database terminology, we call it CRUD operation. Create, retrieve, update, delete. CRUD, C-R-U-D. And of course, we need to think about other aspects like securing your data, safeguarding the data integrity. You will understand what does it mean later. Backup and recovery, because sometimes your database disk might crash, and managing transactions and so on. Those are some additional things. It's not just save, update, delete, retrieve. Yes, those four operations are important, but addition, there are some other securing, backup and recovery, integrity, transaction handling, and so on. Right. So therefore, let's first try to understand or categorize data. Of course, we discussed this in the very first day also under introduction to ICT. What are the types of data? Right. So what are the three types of data? Structured data, semi-structured data, unstructured data. So those are the three type of data we are interested. Or any data we can subdivide into these three. Again, it's very difficult to draw a line and say these are the things, especially these are very gray areas, sometimes somewhat structured, somewhat semi-structured. Okay, so therefore you can't just draw a line and say these are structured, these are semi-structured, these are unstructured. But in general, with common sense, we can say, okay, this is more into a structure, this is more into unstructured, this is more into semi-structured. Okay. Right. So what is mean by structured data? So structured data means data with well-defined structure. Right? Well-defined logical or semantic structure. So this is what we are really interested in A-level ICT database subject, structured data. Because we can keep those data in relational databases and manipulate using SQL. SQL stands for structured query language. You can see that also has the word structured. Right? Query structured data, language to query structured data. And in this particular subject, we are pretty much almost 100% we are interested in structured data. So structured data is the typical data that we process in information systems like employee information, students information, marks of a student, hotel room reservation details, order details, payment details. So well-defined structure like student name, student ID, student gender, student contact details, right? Order ID, order date, order amount, order type. So well structured. Subject versus marks, your exam results. So we call them structured data. And when it comes to information technology, we are more comfortable handling structured data. And only recently we start seriously processing unstructured and semi-structured data. Okay. Structured data. And we can use relational databases to easily keep or store structured data, query, update, delete. So second type of data is called unstructured data. So as the name suggests, unstructured means there's no structure or there's very little structure. Very little structure. Sometimes we call these big data. Another name for structured data is what? Big data. For example, if you take audio, video, images like photos, those are extremely unstructured. But if you take something like web content, email content, social media content, so those are also pretty much unstructured. Pretty much unstructured. But those are a little bit more into the semi-structured. But definitely audio, video, and images, they are pretty unstructured data. So unstructured means you can't find a structure behind that. Very difficult. Okay, very difficult. Usually those are multimedia data, but some textual data also we can take. If it is like article, essay, something like that. Okay. For unstructured data, we have special databases. For example, if you take big businesses like Google, YouTube, so TikTok, Instagram. So you can see they are pretty much working with unstructured data. So therefore, we can't forget it. It's a big business. And also, if you take CCTV camera recordings, unstructured data. So robotics, so they need to process unstructured data through their cameras so that they can identify obstacles and so on. So therefore, it's a serious stuff, processing unstructured data. But of course, we are not interested in this subject. We are interested in structured data. Okay, like student details, employee details, payment details, order details, and so on. And in between structured and unstructured, we have something known as semi-structured data. Again, as I told you, you can't just do a line and say these are semi-structured. It's just it, it's just our gut feeling, we can say with experience, these are more in between data. Some web contents, right? Some social media contents, as I told you, those are more mixture of structured and unstructured. And there are some special data formats like XML, JSON to work with semi-structured data. And again, we are not interested in semi-structured data, but just be aware that there's something called semi-structured data. And we can use technologies like XML, or it's not technology, basically data formats like XML, JSON to handle our semi-structured data. But for unstructured data, very little data format. Okay, very little data format like audio, video. Of course, there are file types, but the data formats are very, very much unstructured, very low level. Right. So now you know that there are three types of data: structured, unstructured, and in between or mixture of things, semi-structured. And in this subject, we are more interested in structured data, saving, updating, deleting, retrieving structured data. Right. So now let's look at a little bit of history, because we always look at a bit of history. Right. How the database management, especially database management related to structured data, evolved. Okay. So before computers were there, of course, we had no other option but manually handle our data using files, folders, paper, pencil, and so on. So then came the computers from 1940s, 50s, until around 1970s. So the approach was use computer files. Of course, the manual systems are still used, but part of the manual systems were transformed into computer-based files. like a text file and so on. Still, we use computer-based files like our Word documents, PDF files, but those are not mostly for data handling, rather for documents. But till around 1980s, files were mainly used for data handling. But these days, we don't use computer-based files for data handling much. So rather, we use database management systems. Okay. For example, your exam marks are in a database in the Department of Examination. Right? So if you take supermarket, all the inventory data, payment data, those are not kept in computer files. Rather, those systems are connected to databases. So therefore, how it has evolved? Manual or physical file-based systems, computer file-based systems, to database management systems. So of course, our subject is database management system. Okay. Now, if you have any questions, you need to ask. Okay. If anything is not clear or if you need a little bit more details. Right. So let's take one by one. What is the approach? What are the pros? What are the cons? Positive things, negative things. Okay. Right. Manual or physical file-based system. Physical file-based means paper-based. Manual means humans manually manipulating. You write it in a paper. Maybe someone fill the form. You collect it to a file. Those files are kept in folders. So if you take government office, AG office, land registry, you will see the manual physical file-based systems still in use. If you go to police station, so they still use it because they are not evolving. Right? So the moment when we say physical file-based system, paper-based files, maybe forms, put it into uh, forms, put it into files, then those files are in folders and so on. Maybe put it in a cabinet and people process it. Okay. Right. So a lot of disadvantages. Number one is these when you put it into the physical files, these files tend to degrade with time when they're exposed to sunlight, moisture. So those content tend to degrade. And if someone wants to search something, extract some data, it's very inefficient because humans need to look at it. And also difficult to transfer because you need to transfer it physically. Sometimes maybe a particular file from Jaffna office. So you need to take it to the Colombo. Just for that file, sometimes there's a vehicle going. Just to transfer that file, maybe just someone more to approve it. So very inefficient. Right? Very inefficient. And also you need physical space to keep those files, folders. And people can do a lot of illegal things, change those things. So many issues. So many issues with physical or manual file-based systems. Okay. So if a particular organization still use it, basically they are very corrupt. They want to deliberately delay things and get bribes. Especially private sector, we don't use manual file-based systems anymore. Okay. Because it's so full of issues, corruption, inefficiencies. And then came computer file-based systems. Right? So 1950s, 60s, 70s. So that was the main approach before databases came. So now what happens is we keep data in files, but in computer data files, and applications access those data files. Now, obviously, it is more efficient to store. You don't need a lot of storage. There's a hard disk, right? And we can transfer it through internet. Right? We can transfer our files through internet network. We can process it fast. We can update, delete fast, search it fast. Right? We can secure it. So many advantages. So many advantages. Okay. It's more efficient, easy to transfer, efficient for processing, need less storage, need less physical space. You can backup it. It won't naturally degrade like physical files. So it's a good move. But these days, we don't use much file-based systems also. Why? Because now we use database management systems. So that means file-based system is good, but database management system is better. So we can't say file-based systems is bad, but database management systems have all the good things of file-based systems plus additional good features. So database management system means, so you have a software called DBMS, like Oracle, MySQL, Access, Microsoft SQL. So those are database management systems, DBMSs. And we let our data managed by those software, maybe one of those software. Okay. So then all our applications or some of our applications connect or communicate with the database. So that is the difference. In file-based approach, our applications are communicating with files. Most of the time, different applications has different set of files. And there's no standardization about these files. It's difficult to share files between applications. So those are the disadvantages of file-based system. What are the disadvantages of file-based system? No standardization for file formats. Most of the time, one file cannot be shared with another application because those file formats are application specific. There's no common structure saying this is the structure of a file. So developers decide according to their requirement what is the structure. Then that structure may not work for another program. Okay. And also processing a file is a little bit more, for programmers, it's more work. You need to open the file, read it, close it. So therefore, file-based system is better than manual system, but it has its own problems also. And almost all these problems are solved when we go for databases. Okay, database management system. So number one advantage is now we have common single central storage. All our applications to connect, accounting systems, inventory management system. So they don't keep their own files. So they all connect to the central database. So that is advantage. So then data is not duplicated. Here, same data might be duplicated here and there. Right? So now we have the central location, and therefore we can apply security in a one place. And also we have common database structures, common structure, what is known as table. So those are well-defined structures. Tables have fields, fields have data types. There's a concept called primary key, foreign key, standardized. Whether you are using Java or Python or C#, you can communicate with database because those are standard features now. Advantage. And also, in order to communicate with the database, we have a standard language called SQL. Whether you are developing a PHP program or Python program or Java program, so you can use SQL, structured query language, which is a standard thing. Okay. So it's a win-win situation. So all the good features of file-based systems plus a lot of bad features of file-based systems are eliminated. What are those added advantages? Central repository rather than isolated data stores. Common structure, standard to keep your data. Common query language called SQL. Standard query language. So central security. And also these database management system provide additional features like security, backup and recovery, transaction handling, maintaining integrity, performance optimization. So therefore, in modern software development or modern applications, we almost all the time go for DBMSs, not computer file-based systems. But remember, we work with the DBMS, but internally, DBMS keep your data in files. So therefore, don't think that files are not used. Yes, still files are used to keep your data. But only thing is, as programmers, when we develop programs, we don't want to think in the file level. We just think at a higher level. So we call it higher abstraction. Higher abstraction, which is easy to work with, called tables, relationships. So our programs refer to tables, relationships rather than files. And DBMS internally manage or map tables into files. That is how database management system works. Okay. So if someone asks what are the advantages of DBMS, the number one I will give is DBMS give a high level abstraction for the programs to communicate with. So files are below, but DBMS provide high level abstraction where you have concept for table, relationships, and so on, and let you work with SQL rather than directly work with file handling, which is more convenient for your applications. Okay. And of course, DBMSs provide additional support for security, backup and recovery, transaction handling, integrity control, and so on. Right? So if someone asks why do we need databases now, you must have a solid answer. Solid answer. The best answer must be with you. Okay. Because before starting database management system subject, you must know what is a database and why are we interested in databases. Otherwise, after doing all the things, if someone asks what is a database, sometimes student doesn't know. Student has no clue of what he or she has studied. Just memorizing and rehearsing like a parrot. Okay. Don't do that. Right. Any questions up to this point? So we discuss the manual DBMSs or manual management for computer file-based data management and also computer database approach. So what are the pros and cons of each approach? Especially what are the advantages when it comes to database management systems? Okay. So there are database management systems like MySQL, Access, Oracle, Microsoft SQL. Okay. Right. So what we have discussed is evolution of data management. So what are the three stages? Manual data management, computer file-based data management, use of database management systems. So now we will look at evolution of database management system. It's something like manual data management, computer file-based data management, database management systems. Okay. Now we look at this in more details, how this evolved. What are the different sub-stages? What are the different sub-stages in this database management system? So basically, database management systems came into the picture in somewhere around 1970s, latter part of 1970s. So up to 1970s to maybe 2024, some major stages in or major types of database management systems. Okay. Right. So we are really interested in relational DBMSs. But that is not the first type of database management system people or computer engineers, software developers develop. So the first type of database management systems tried out in 1970s, we call it hierarchical DBMSs. So then came the network DBMSs. So then came relational DBMSs, especially in 1980s. And now we have object relational DBMSs, object DBMSs, and even NoSQL DBMS. Of course, this is not in your syllabus, but just I added it because you may have heard this word, NoSQL databases. Okay. But these things are mentioned in your syllabus. Okay. But we are really interested in relational DBMSs. Remember, we are interested in more structured data. Okay. Structured data. But I told you that these days we are more interested in semi-structured, unstructured also. So that is one of the reasons why we are interested in NoSQL databases, because NoSQL databases are really good at managing semi-structured data. Okay. Right. So let's take one by one. So now we are into the evolution of database management systems. Okay. Right. So the first type of database management system tried out by software developers, software engineers, we call it hierarchical DBMSs, hierarchical database management systems. So hierarchical database management systems manage your data as set of hierarchical tables. Set of hierarchical tables. So this approach came in 1970s. Because when we look at organizations, you can see there's a hierarchy. If you take a school, principal, section heads, then class teachers, and so on. If you take a business organization, maybe CEO or managing director, maybe section heads like HR manager, finance manager, or maybe different set branches have branch managers. Even a government, there's a hierarchy like president to the ministries and so on. So therefore, when we look at our environment, we can see there are hierarchies. And therefore, they thought, because there are hierarchy in control, management, why don't we just design our database also as a hierarchy, hierarchical thing? So that is a natural thinking, natural thinking. For example, let's say we are managing students in the school. Maybe there's one table called school, maybe primary section and secondary section, maybe section heads, maybe then grades, then maybe class teachers. So let's model like that, or let's handle our data like that. School related data, section related data, grade related data, under that class related data, maybe under that student related data. So that was the thinking behind hierarchical databases. So database is created as a hierarchy of tables, hierarchy. So the idea borrowed from the real world organization structures, right? Hierarchy in traditional organizational structures. So they look at the organization and they thought, okay, let's have the database also like that. So the obvious advantage of using hierarchical database management system is tight control over the data. You get very good control, because you need to go through the hierarchy in order to access data. But the biggest disadvantage is it's very inflexible, lack of flexibility, because you must go through the hierarchy. Okay, so when there's a hierarchy like this, so try to understand, you should be able to understand this. So if you want to relate this particular data with maybe this particular data, so you need to go through the hierarchy. There's no alternative. Right? For example, you need to go through this path. So this related to this related to this, like this. There's no way you can directly relate this and this. If you want to relate this and this, right, you need to go through this hierarchy. Therefore, it's not very flexible. It's very rigid structure, hierarchical databases. Tight control, which is good, like tight control, tight security, but at the same time, it's not efficient. It's not flexible. Like taking approval from one government institute to another government institute. You must go through the hierarchy and get the approval. Okay, so therefore, so they found that this is not the way to go. Of course, they tried it, but they found that this is not the way to go. It's very inflexible. It's very rigid. So that is where they tried out the other extreme. So this extreme type situation, right? Hierarchical is extreme, strict situation. Like a school, you know that school is a very strict place, like a prison. A lot of strict rules are there. So that is why students prefer tuition classes, because tuition class, there's no hierarchy. Just a teacher come to the class, students come to the class, conduct the class, and students happily go away. There's no section, there's no principal. It's very flexible. So even student can change one tuition class to another tuition class. You don't need approval from principal and so on. Okay. So that is where you have extreme sort of a freedom. But there you lack control. So that is exactly what computer engineers, software engineers tried out, other extreme, after hierarchical system, because hierarchical system is very restrictive. So they tried out network DBMS, right? Network database management systems. So in hierarchical, you must follow the hierarchy. In network DBMS, you can freely relate one table with another table. Very little restriction. If you want to relate this one and this one, you just create a relationship. So when you see the word network, don't misunderstood, right? Sometimes you get misunderstood by thinking this is a computer network. No, this has nothing to do with the computer network. So network means we freely interconnect. Actually, computer networking also we freely interconnect. So network database means you don't follow the hierarchy, strict hierarchy. Rather, you freely connect these things. If there's a need, you relate those. If there's a need, you relate maybe this and this. So then the result is something like a network. That is why we call it network databases. So that this is the other extreme. Hierarchical database is the extremely tight control. Network database management system is extremely flexible, extreme liberty, freedom, right? Extreme freedom. And of course, now that problem is no longer there, because now you don't need to follow hierarchies to relate data. So therefore, it's efficient. You can, without following the hierarchy, you can relate data. So that is a good thing. High flexibility. But now, because this is the other extreme, there's no control or very little control. Because we need bit of control also. Now, we like flexibility, but we don't want to lose complete control. So therefore, the disadvantage, because this other extreme, you lose control. You don't have any control, sort of. Because this is the other extreme situation. So you can see people tried out the two extremes. Extremely tight structure, extremely liberal structure. But extreme tight structure is not efficient. Extreme liberal structure, you don't have any control. People can misuse. And sometimes it can be overcomplicated because of too many relationships. So what is mean by relating to data? So I told you that here now you can relate data freely. Sometimes you don't understand what I mean. What is mean by relating data? For example, there's a customer, there's an order, And this order is by a particular customer. So then there's a relationship between order and customer. That is what is my relationship. So this order is for this particular customer. And maybe this payment is done by this customer for this order. So that is how relationships are built. Right? It's basically instances of your table or records. So this student belong to this particular class, and then this class has these students. And this exam is for this class. It's grade 11 exam. And maybe this particular teacher is for a particular class. So those are for relationships. So in network DBMSs, you can freely relate these things. Maybe this teacher is related to this exam is related to this class is related to this student, and this student is related to this teacher. Sometimes it's too many relationships because there's no restriction. So that is mean by if you misuse it, it ended up in no control, too many relationships. Whereas in hierarchical databases, too many restrictions, not very efficient. So therefore, now we have settled to an in-between situation. That is fairly good control and fairly good flexibility. Not too much of control, not too much of freedom. Somewhat control, somewhat flexible. Good amount of flexibility and freedom. So that is how relational databases management systems evolve. So what is mostly used these days, and of course in your syllabus we 100% cover relational databases. Right? So when we say Access, Oracle, MySQL, Microsoft SQL, so those are our relational databases. Okay. So relational database management system is not a hierarchical database. It's not a network database. Okay. So therefore, you can't just blindly create relationship between tables. At the same time, you don't need to follow strict hierarchical rules. So you get a bit of flexibility, but that flexibility you must follow with some discipline, some theory, some control. So you can't say it's no control, and also you can't say it's too much of control. It's a bit of control based on theory. Based on theory. So therefore, there's a theoretical background also behind relational DBMS, but that theory we don't study in A level. We call it relational theory. It's a mathematical topic. We don't study that in your A level, but you must remember there's a theory behind that also, mathematical theory, which is good. Right. So therefore, advantage is when it comes to relational databases, a good combination of control and flexibility. Not too much of control, not too much of flexibility. Just the right amount of control and flexibility when it comes to relational DBMS. Okay. So remember, relational DBMSs are the most widely used right now. Maybe I would say more than 75% of the time we use RDBMSs. But it doesn't mean that this is the best. So there are some drawbacks of relational DBMSs. So therefore, still this is the most popular, right? But in some situations, we need some alternative DBMSs, especially in special cases. General cases, RDBMSs are really good. But some special cases, sometimes we go for different approaches or new approaches. So one of the disadvantage of RDBMS, or relational database management system, is lack of support for object-oriented programming. So the simple reason is relational database management systems came in 1980s. Object-oriented concept evolved in 1990s. So therefore, obviously, before object-oriented concept came, relational databases came. So therefore, consciously, it has not added any support for object-oriented programming. That is natural thing. That is natural thing because this came after this. So therefore, it's a little bit of a disadvantage of going for RDBMSs. Okay. But now what we are doing is the RDBMSs are adding more and more support for object-oriented. Okay, object-oriented features. Though object-oriented came later, because relational database management system vendors, they also try to modify it, improve it. So they are now gradually adding some object-oriented features. And those relational DBMSs with some additional support for object-oriented features, we call it object relational database management systems. Right? Object relational database management systems. So object relational database management system means it's a relational database management system with support for object-oriented concepts. It's like a hybrid vehicle. Remember, we used to have hydrocarbon or petroleum vehicles. So then came the electric vehicles. Electric vehicles. So petroleum vehicles, electric vehicles. And so this is like relational databases. This is like object databases. And you know that we have hybrid vehicles. Hybrid vehicles use bit of petroleum and bit of electrical. It try to take best of both. So similarly, we have the relational databases, we have the object databases, and we have object relational databases. Okay. So object databases are database management systems fully supporting object-oriented concepts. I know you don't know what is object-oriented is because, by the way, it is not in your syllabus fully. And also you will learn a little bit about object-oriented concept when we are doing programming. Just remember, I told you when we do the system analysis and design, there are two ways you can do programming, non-AI programming. What are the two ways? Structured approach, object-oriented. So what we discuss is structured system analysis and design in your previous topic. So there's another approach called object-oriented. So object-oriented analysis, object-oriented designing, object-oriented programming. So we did not discuss this. But remember, there's another approach called object-oriented software development. Now, when we go for object-oriented software development, we use object-oriented concept like class, object, inheritance, polymorphism, encapsulation. That's supported by your programming language like C, C++, Java, Python, support object-oriented concept. But your database, your relational database doesn't support object-oriented concepts. So therefore, object-oriented database support these object-oriented concepts also, like inheritance, polymorphism. And what is the in-between one? In-between one is called object relational. So object relational database support both relational concepts and object-oriented concepts. Because we are in a transition, still the object-oriented concepts are not 100% evolved, especially in database side. So therefore, we prefer, if you need object-oriented support, and also we don't want to get out of the relational side, we go for object relational databases. Okay. So object databases support object-oriented concepts like class, object, inheritance, encapsulation, polymorphism, which are modern programming techniques. So now in between relational and object-oriented we have, because relational databases are more suitable for structured programming. So in between one of what we have is what? Object relational databases. Support for both relational and object-oriented concepts. So relational are more related to structured. Okay, so it's like a easiest way to understand it is like a hybrid. So when we need object-oriented concept, you have object-oriented support. When we need structured concept or relational concept, you have that support. Best of both. support for both. Okay. Right. As I told you, this is not in your A-level ICT syllabus. I just added it for your information. So now we use more and more unstructured data and semi-structured data, especially social media. Okay. Facebook, X, Instagram. Of course, Instagram heavily use unstructured data, also a lot of images. But if you take Facebook, X, we heavily use semi-structured data. So semi-structured data need more flexibility. So that is where we have another type of databases called NoSQL databases. So to handle unstructured and semi-structured data, it is more flexible for applications like social media, like content publishing, storing session data, mobile computing. Okay, so just keep that also in mind, though it is not directly in your syllabus, because that is good for your confidence. Because when you go to the exams, what you take is your confidence. So when the exams are nearing, you must feel more and more comfortable, confident. You must be waiting for the exams. But if you just keep memorizing things without understanding like a parrot, the more you are getting closer to the exam, more you are uncomfortable. More you are stressed. So don't do that. So therefore, it's okay to learn a little bit more, which gives you the additional confidence. Okay. Right. So what are the database management systems we discuss? Hierarchical, network, the two extremes, relational databases, object relational databases, and object databases. Those are in your syllabus. Additionally, I explain you what is NoSQL database. It's more support for semi-structured data. Semi-structured data. Right. Any questions? Because we are almost at the end of the topic one. Right. No questions. Okay. Right. So no questions means 100% understood. Okay. Right. So finally, we'll look at, because we need a way to look at databases, especially relational database management systems. Architecture. So this architecture is called ANSI Spark 3-tier architecture. ANSI stands for American National Institute. So even when we say databases today, what are the databases come to your mind? Oracle, Microsoft SQL, Access, MySQL. So those are all developed in USA. Right? Oracle is a US company. Microsoft, obvious US company. MySQL is also evolved under Oracle. Now it's open source, but it's pretty much communities from USA. So therefore, just like the computer operating systems evolved in USA, databases also, majority of databases evolved in USA. So therefore, American National Standard Institute identified this importance of standardizing this, because otherwise there will be a lot of conflicting situations. So this came up with a standard architecture. It's a layered architecture. So this is the second time we look at a layered architecture. Okay. So in the very first day when we start ICT, I think the second day, we discuss a layered architecture. That is, we look at the computer as layers of hardware, firmware, system software, and application software. And of course, the users, liveware. It's a layered architecture. Lower layers support upper layers. Hardware support firmware, firmware support system software, mainly operating system. On top of operating system, you have the application software. And on top of the application software, people use it. So it's a layered architecture. And you learn another layered architecture. Can someone tell me what is the second layered architecture you learn? Anyone? So This is the layered architecture for computer system. Anyone, what is the second layered architecture you learn? Because we have done it. Anyone? So if you are a confident person, you must have an answer. If you have done studies, but if you are just attending sessions, not doing your studies, then of course you don't have any answers. Anyone? What is the second layered architecture you learn in A-level ICT? No one. That is a tragedy. So you learn 7-layer OSI architecture developed by ISO, International Standard Organization for Network, physical layer, logical link layer, network layer, transport layer, session layer, presentation layer, and application layer. That is a layered architecture. So lower layers support upper layers. So here you have the MAC address, here you have the IP address, here you have the switching, here you have the routing, here you have the session handling, here you have the applications. So that is also layered architecture. So this is the second layered architecture you learn. And third layered architecture you learn in your A-level ICT syllabus is ANSI 3-tier architecture. Spark is basically the project name. So they are project that develop this layered architecture. So ANSI, American National Standard Institute, came up with this layered architecture for databases. Right? So that the database management system vendors like Microsoft, Oracle, they can work on a common structure rather than having their own way of doing things. Right? So the structure is called ANSI 3-tier architecture. It's a 3-layer architecture. So what are the 3 layers? The lowest layer. Now, this is to look at the database management system. Of course, database management system is a software. So that software, we can look at it in 3 layers. For that program that we use to manage our data. What are those 3 layers? Internal law, physical layer or schema. Logical law, conceptual layer. External law, user layer or end user layer. Okay. From down below, internal law, physical layer, logical law, conceptual layer, external law, user layer. So basically, these are 3 views of the same database. So this is the end user's view. That is why we say external or user. This is how end users look at the database. So they are more comfortable looking at database with the asset of forms, reports, views, and so on. So they are not much interested in thinking in terms of tables, files, and so on, because these are the users. Right? So when you go to ATM machine to withdraw some money, you want to see some forms so that you can log into the system. Maybe some views, like when you query, you get the results. And if you are a manager, some reports. So they are interested in these things. And yes, ultimately, from your database, you can generate these things. So therefore, this view is called external law user layer or the user view or user schema. And if you go to the other extreme, we have the internal law physical scheme. Physical means more closer to the reality. So reality is when you keep data, we keep data in files. Even your operating system is set of files. Right? When you install a program, software, you copy set of files. So therefore, every program is set of files. Your data is also saved in set of files, data files. So therefore, reality is ultimately your data is saved in files. And that view is called internal or physical layer. Internal means As a user, you don't need to worry about this layer, this view. Even as a software developer, you don't need to look at this view. So this is for internal people. Internal means someone who developed the database management system, someone who developed Oracle software, someone who developed MySQL software, or else someone like a database administrator who want to take backup and so on. So then you must know where the files and so on. So this view is for database administrators or system developers. System developers means someone who develop database management systems. Okay. And the layer that we are more interested is the middle layer. So this is the software developers view. So when we develop software, IT professionals, so we look at database as set of tables or relations, relationships, and so on. So that is why I told you that this is, if you look at these things, that is file-based system. I told you that databases gives you a high level of abstraction, logical view for the software developers. And that abstraction or the logical view is called the logical schema or the conceptual scheme. So software developers, we are interested in this level because it's more convenient, easier to work at this level than file level. And of course, we can develop these things for the end users. So we do the mediation. Because end users, they don't even like to look at tables and relationship. They want forms, report. So our task is look at the database as set of tables and relationships and manipulate your data at this level and facilitate these forms, reports, fields, and so on for the end users. But as software developers, we don't need to look at these things in detail. So that complexity is handled by your database management system. And if you are a database administrator or someone who develop database management systems, maybe you are interested in these things. Otherwise, you don't need to look at these things in detail. So you can just stay in this level most of the time. Okay, so this is super, super important. Remember, maybe in the very first day when I explained you the three-layer computer system, hardware, firmware, system software, application software, maybe at that day, you were not that convinced. But when we keep moving, fetch, decode, execute cycle, representing data in the computer, now you know that at application layer it is maybe Python program, Java program. At this level, of course, your data is no longer 105 or hello, it's set of ones and zeros. These ones and zeros are represented by digital signals, and these digital signals going through logic gates. And these logic gates are made of transistors. Right? So when both are one, only one in AND logic. So now you have better understanding, right? So how did you understood it? How did you understand it? Using the layered architecture. So you know that your data is represented in numbers like 2's complement, IEEE, floating point, ASCII. And you know that these data going through logic circuits, and which logic circuits are determined by your high level program, your Python program, Java program. So same level of confidence you must have about how the database works. So how do you understand the database? Because database management system is a software. This particular three-layer architecture. External layer, logical layer, internal layer. And we are more working with this layer. So DBMS have exposed concept in this layer for the software developers, which is easier than working in this layer. And our task is working in this layer so that indirectly we are working with this layer, directly we are working with this layer, and then we facilitate these layer concepts for the end users because end users are not software developers. Got it? Because there's nothing called half understood. You can't memorize these things without any feeling about it. It doesn't work. It doesn't work at all. So that is why I'm asking you to ask questions, right? If anything is not clear, if you need a little bit more details, Now, if anything is not clear, yes, you can talk to me at any time during the class, after the class, and go to the YouTube and do a search. ANSI 3T architecture, different people explain it. Maybe someone from Oxford University, someone from right uh, MIT University, USA, and also that is if you go to YouTube, do a search and follow some tutorials. That is why you are learning it in English medium, right? You less and less rely on teachers. Like those who are learning in Tamil Sinhala, so they 100% rely on their teachers. So that is why they are right, like a slaves. But you guys are not like that. So you can communicate with ChatGPT. So you must now you are living in 2025. Always remind it, right? Go to ChatGPT and ask. So you can ask in a very polite manner. Okay. Can you explain if you need more details? Because you are not isolated now. Can you explain the NC three-tier or NC database architecture? Maybe you can use because you are doing A-level ICT in simple. Because you guys are doing A-level ICT. Otherwise, your ChatGPT might think you are doing a degree, you are an engineer. Okay. Or you can say for a A-level ICT student. Okay. Or you can write like that. Because now you have those features. For A level, say because your A level ICT syllabus is pretty much like computer science syllabus. So therefore, if it is A level ICT, ChatGPT will give oversimplified. I told you in the very first day, Sri Lankan A level ICT is more advanced than Cambridge, Parson, computer science. So therefore, don't use A level ICT when you communicate with these tools because in those countries, A level ICT is just a set of computer packages, no serious programming network in databases. So I will say A-level computer science student or in simple. Okay. Right. So you can see internal layer, physical layer, what it is, purpose, key concept. Okay, like physical storage, indexes, conceptual layer, right? Purpose, key concepts, external layer, what it is, purpose. It allows users to interact with the database. Key concepts like user view, access control, security, data representation like reports. And still we have not discussed about the data independence, okay? Physical data independence, logical data independence. So just use this. Okay? It helps computer science students to understand how databases are structured and managed. This architecture is often referred to as three-tier architecture or the three-schema architecture. So likewise, so you have a lot of resources. Right? You have a lot of resources. Use those. Go to the YouTube. Follow a tutorial. Right. So therefore, if you have any questions, yes, maybe you don't ask from me, but ask from ChatGPT. Right. Do a Google search. Right. So this is as a logic. How do you look at the database? As a logic. Remember, we are interested in logical layer. Right. We are interested in logical layer or conceptual layer. So you look at the database as set of tables or relations. And each table you have records, right? Student records, customer records, payment records. So we can look at it as a table. Actually, there's nothing called table in reality. In reality, what you have is files. But database management system, that is what I mean. What I mean by gives you abstraction, conceptualization of files into more easy to understand logical view called tables. And each record has set of fields, maybe student record, student ID, student name, contact number, email. So this is how as a logic, you look at the database. So this is what we are really interested in. Logical or conceptual layer. This is how your database management system exposes the database to you as a database designer, software developer. But I told you in reality, your data is saved in files. So therefore, reality is physical or internal layer. So there you look at it as your database as set of files. Right? Set of files. And again, each file has set of records. Each record has fields, right? Employee record has fields, employee ID. And these fields, because ultimately those are saved in the computer hardware, bits. So particular field has set of bits because by ultimately those are saved in ones and zeros. So look at this. Don't afraid to look at the reality. Right. So technology students, engineering students, they don't run away from reality. They face the reality. Science students, they face the reality. So now, can you understand the difference between logical view and physical view? Database is set of tables. Each table has records and each record has set of fields. So these fields have numeric character data. Okay. Whereas physical layer, your database is set of files and each file has set of records and these records have set of fields and these fields ultimately, because binary, reality is binary, set of bits. But we are more interested in this layer because database management system hide this complexity of physical layer. That is handled by DBMS. Okay. Right. So remember the ChatGPT discussed about the independence. I just asked, explain it so that the computer science student can understand. So then it start explaining that it start explaining data independence. Data independence, physical data independence, logical data independence. I asked you to explain it to a computer science student, right? So therefore, because it's relevant to the computer science students, the ChatGPT explain it. Of course, it is relevant for you also. Because I told you, A-level ICT in Sri Lanka is like computer science. Not like computer science, it's computer science actually. The name is, only the name is different. Right. So this is the three-tier layer ANSI architecture. External view, logical or conceptual view, physical view. External view, this is how different users look at it, like manager, data entry operator, section head. The conceptual view, that is the view of the database developers, designers, and the reality, physical view. The database administrators, database system developers view. So we have three layers: external layer, logical or conceptual layer, internal or physical layer. Okay. So there's a mapping between these layers. So this mapping is pretty much software developers need to do. We need to develop this mapping and create these things. So this mapping is pretty much done by your DBMS. Your DBMS is happy to accept your SQL queries, which you are referring to the tables, relationships, and handle the internal things. Relevant files are updated by DBMS. Your Oracle database management system, Microsoft SQL database management system, MySQL database management system, and so on. So this mapping is handled by DBMS. But this mapping must be handled by developers. Okay. So therefore, we are more interested in this mapping. We must be able to communicate with this and develop these things also. Of course, we need to develop these things as well. So basically, we are developing these things first and then these things. So these things are handled internally. But if you are a very technical person, you will be able to take a little bit of control of these things also for performance security. Okay. But in A-level ICT, we are pretty much interested in working with this. We are not much interested in this because this is covered in your web development. For example, in PHP, you will learn how to communicate with database and put it into a web page. When you do programming, Python, you will learn how to communicate with your database and present your record into the application. So therefore, yes, we are interested in this, but these are handling our next two topics. What are our next two topics? Programming and web development. So in programming and web development, we will look at how to present these data as set of views reports. So in this subject, so you must know what you are doing at each stage. In this subject, you are interested in communicating or building the database at this level. You will create tables, you will create relationships. Okay. And your web development and programming subject, you will interact with the database at this level database and insert data, query data, update data. And this is not something we do because let the DBMS handle this. So is it clear? Is it clear? Okay. Right. Right. So then there's a concept called logical data independence and physical data independence. Okay. So what is mean by physical data independence? So physical data independence means you can do some changes to physical artifacts like file structures and so on without affecting the logical concepts like your tables. That means without touching your tables and relationships, you should be able to do some changes to the files. Okay. So that is something database management systems provide you, that feature. And that feature is called physical data independence. Okay. So that is not something you do. That is something your DBMS provides. Okay. So that means without touching your tables, you can decide the file structure. You know that in operating systems, we discussed that there are different type of files, index files, contiguous files, right? So we can change those file structures using index files and so on without you change your tables and so on. So that is good for performance, security, reasons we should be able to do some changes without touching this. Because if you touch this, maybe you need to touch this also. That is called physical data independence, which is a feature supported by most database management systems. So second, data independence is between logical data and external data. So that is called logical data independence. So that means we can change, not 100%. We have bit of flexibility to change these things like table structures, relationships, not 100%, somewhat. We have the flexibility to change the conceptual schema things without much effect in the external law user layer concepts. But again, I keep giving you the word. We have a little bit of flexibility, not 100% flexibility. It doesn't mean that you can completely change these things without affecting this, but you have a bit of flexibility, right? Little bit of flexibility. Here also we have somewhat flexibility. Actually, here we have a little bit more flexibility, but here little bit of flexibility. But sometimes if you do big changes here, of course, you need to go and change these things. Okay. So that is called physical data independence. That is changing the physical layer things independent of logical layer things. Logical data independence means changing the logical layer concepts without affecting the external layer concept. Again, I'm telling you, not 100%, you have bit of flexibility. So DBMS providers try to provide this physical data independence and logical data independence in their architecture. Okay. Again, how it is done? don't worry too much. Okay. So maybe gradually when we learn, because this is not the end of the database management system, we will be doing this for another at least 4 or 5 classes. So during those discussions, you will get better understanding about the logical data independence and physical data independence. So therefore, maybe you have not understood this concept 100%, these two independence. Don't worry, just keep that in mind, keep that as an open thing, and make sure that you gradually understand it, okay? So what is logical data independence? Changes to the conceptual schema should not necessarily require changes to the external schema. That is the upper one, right? Not necessarily, right? Yes, sometimes you need, but not always. So that means there's a room for doing changes to the conceptual schema without affecting external schema. I think this is easier to remember. Not just remember, understand it. Okay. Don't just memorize. So then what is physical data independence? There's room for doing changes to physical schema like file structures and so on without affecting the conceptual schema or the logical schema. Again, there's a room for. It doesn't mean that always. There's a room. Some flexibility. Or in technical way, you can say you can change the physical artifacts without affecting the logical artifacts. Again, some, right? Not always. Okay. So I think we covered a lot. Right? So evolution of data management, manual systems to computer file-based to databases, then evolution of database management systems. One extreme case of hierarchical databases, the other extreme flexible case of network databases, then somewhat in between situation of relational databases, and then the object relational databases and object-oriented databases, so object databases. So then we discuss the ANSI 3-tier architecture. The physical law internal tier, logical law conceptual tier, external law user tier. What are the concepts behind external tier? What are the concepts behind logical tier? What are the concepts behind physical tier? Then we look at what is physical data independence, what is logical data independence. In a way, a lot of things, in a way, not a lot of things, right? Just a small set of things, if you have understood it. Right, so now we'll look at one more concept because this is the introduction to DBMS. Okay, so our topic is introduction to DBMS. Just to give you a gentle introduction, little bit of history, introduction, classification. Right, so this is another way of looking at database management system, right? DBMS or database. So your database obviously keep data. Of course, that is why we call it database. Maybe student related data, their attendance, their exam marks. If it is supermarket or something, inventory related data, sales related data, customer related data. So obviously you need to keep data. And your DBMS keep not only data, it keep metadata. Metadata means data related to data or data about data. Another name is what? Data about data. So maybe this data is maybe one Nimal Note 77 blah blah blah. Say vehicle. To Kamal Note 71 maybe Maharagam. So this is data records. Then what is mean by metadata? So metadata means what is, remember we are more interested in the logical layer. There we have tables, relationships, and so on. Okay. So metadata means data about data. So what is this table name? What are these field names? What is the data type of the first field, data type of the second field? Maybe this is text, maybe this is number, maybe this is date. Those are called metadata. What is the primary key? do we have foreign key, any other constraint about your data and tables, relationships. So those are called metadata. So you will learn more and more about data and metadata when we proceed, especially design and development. So your database not only keep track of data, your database keep track of data about data. That is your design data and design and other data, right? For example, if you are familiar with Access, initially we will use Access, Microsoft Access, okay? Then we will move on to MySQL, right? So if you are familiar with Access, maybe at least you must have open Access because it's part of the Office packages, just like Word, Excel. And if you open a database, and if you look at open a table, so this is called data. Of course, no records are there. If I had enter data, that is I'm looking at the data. Right, I'm looking at the data. Let me open a different table database with some data. But that database doesn't have any data, unfortunately. Right, so this is data. Okay, student data, one Nimal, partner ID, right? Employee related data. So I'm now looking at what? Data. Data part of the database. But there's something called design view here. I can right click a table and say design view. Now I can see what are the field names, right? So what are the data types and any other constraint when I click on a particular field, right? Some constraint, more validations. And now I'm looking at what? I'm looking at the metadata. So here I'm looking at data. Here I'm looking at metadata. So therefore database may keep track of both data and metadata. So now we try to understand database management system little bit, right, bit by bit. So therefore your database management keep track of your data. At the same time, it keep track of your metadata, right? Metadata or the design view in Access. Okay. Sometimes this metadata or that the subprogram that keep track of metadata is called data dictionary or the system catalog. Data dictionary or the system catalog. Or informally, we can call it design view. Design view. This is the data view. Data view, design view. But design view is a informal word. The technical term is your database keep metadata in its data dictionary or the system catalog. But informally, we call it design view, especially in databases like Access. Data is you are looking at the data. When you are developing a software from your PHP, Python, basically you are sending SQL queries to work with data, not with metadata. Right? Work with data. But when you write a query, you must aware of the metadata. What are the table names? What are the field names? Otherwise, you can write your SQL and send it to this. So therefore, you must aware of both data and metadata. First of all, you must aware that there's a data. Database keep track of the data, and database keep track of the metadata or the structure or design view. What are the tables? What are the primary keys of each table? What are the fields? What are their data type? Are there any constraints like default value, unique constraint, any validation? Right, so that is metadata. Okay. So metadata is data that describe the properties or characteristic of other data, like name of the data item or table, data type, length, maybe minimum, maximum values, minimum, maximum width, some other constraints, validations, even maybe a brief description about your table, description about your fields. So those also can be kept in your database under system catalog or data dictionary. So these are the technical terms we use. Okay. Every DBMS provides an interface to look at your metadata, look at your data. Okay. For example, anyway, later we will be using MySQL. I will just show you how to start because I will explain you how to install MySQL and so on later. This is a technical subject anyway, practical subject. So I have something called SAM server where I can start my database server and web server, because web server we need when we are doing web development. That is our next topic. Okay. So I started the wrong application. Right. So now I can access it. I will show you. This is MySQL. To take a little bit of time. Earlier I was looking at Microsoft Access, the data view and the metadata view for the design view. So if I go to MySQL, later we will create some databases using MySQL and write some SQL. Okay. Why is that? Just give me 1 minute. Why it is not up? Right again. Let me try it only once. Otherwise, I can show you next time. So now I can access it. So these are different tables I have. Okay. Even I have some tables created for A-level ICT students, like A-level ICT 24. You guys are A-level ICT 25. So you can see some tables. Now, if I click on a particular table, so now I am looking at the data. I'm looking at the data. So 1, Rehana, 190,000, department ID 2, the employee ID 2, Kevin, 180,000 is the salary, department ID 4. This is, I'm looking at the data view. Okay. So if you want to look at the metadata or the design view or the system catalog, so there's a view structure. Now I know what is the table name, right? What are the fields? Which one is a primary key? Which one is a foreign key? What are the data types? Right? Are there any default values? Is it null allowed? Those are, now I'm looking at what? Design view or the data dictionary or the system catalog. Okay, system catalog. And if you go down, you have a little bit of control over physical layer. Remember, the physical layer has what? Data files, index files, remember? So you must put or map your theory into practice. Now, I told you, usually we don't look at the physical layer. We are more interested in logical layer. This is logical layer. This is, I'm looking at a table. But if you want, you have a little bit of control over your physical layer. For example, this say, this is what type of file index is used, B3 index. Right? For example, if you want, you can change the file structure also. Right? You can go to edit and you can say what is your index type. Is it a primary index? Right? Unique index. So don't worry about these things. What I'm telling is, even you have a bit of control over physical layer, some advanced options, right? Block size. Remember, block size is, remember we discussed about operating systems. Your files are kept in file blocks. Okay, file blocks. So that is if you need a little bit of control over the physical layer. But usually we are not interested in that. As designers, developers, we are more interested in this, the table structure, relational view. That is all about the relationships. Okay, and so on. Right? So the data view, I showed it using Access, which is much more simpler. And also I showed it using MySQL, which is a little bit more sophisticated. So in the first few weeks, we will be using Access. But later, when we are moving to the SQL, we will move on to the MySQL. Okay. So these are technical subject, right? So next three subjects, including this, the current subject and next two subjects are the technical subjects. Database, programming, web development. You need to do practical things. Okay, but not today, not even next class. So after next class, we are into the design and development. Okay. From web development subject, from day one practical. Programming from day one practical. Database from day two practical, not day two from day three practical. Next class is also theory, analysis. But today is the day that you need to have your big foundation. Because if you understand database, web and programming, so your confidence is sky high, including the networking. Of course, networking we have done. Because a lot of students struggle understanding database, programming, web development, and networking. So they can understand the theory, but they don't understand the practical things, technical things. Okay. Right. So that is what is mean by data view and the metadata view, or data view and the data dictionary, or the system catalog. So system catalog or the data dictionary keep the metadata or the design view. Okay. So this is metadata. What is the table name? What are the field names? What are the data types? Maybe length, maybe min max values, any other constraints. Even you can give a description to your fields, description to your table, all are metadata. So if you are looking at these things, so if you are doing changes to these things, you are working with metadata, or you are working with system catalog or data dictionary, not the data. Okay. Right. So now let's look at what are the functionalities of database management systems. Obviously, database management system must be able to support CRUD operations, right? Persist or save data. We call insert, update data, delete data, and retrieve data. So that is our major objective of a database, right? Insert, update, delete, retrieve. Okay. And we do those things using queries, SQL queries. So therefore, your DBMS must be able to manage your SQL queries. Because we send SQL queries from PHP, Python. And also it must be able to handle some security like authentication, authorization, backup and recovery. You should be able to take backups. If there's a crash or whatever, you should be able to quickly restore. Think about something like a database of a banking system. Every second, thousands of transactions are happening. Thousands of transactions, but there's a possibility of a hard disk failure, right? Because nothing is perfect. Right? Your database must be in your hard disk SSDs, but there's a possibility of disk failure, SSD failure, just like your computer can crash. So these computers can crash even more frequently because these computers are so busy reading, writing. So that is where backup and recovery support from the DBMS. Sometimes you don't feel that there's a database failure because there are multiple database disks. Same data is written to multiple disks. So when there's a failure of one disk, still your database, your applications are smoothly running because the same data is available in other disks. So therefore, while your systems are up and running, the network system administrators can replace the corrupted disk. So you don't feel it. You don't feel that so there are techniques for that. And all those features must be supported by DBMSs, not just insert, update, delete, security, transaction handling, backup and recovery support, query optimization, performance optimization. Okay. Okay. So therefore, that is why I told you, I think Monday I told you that if someone asks what is the most complicated software, anyone, what is the most complicated software? What is the most complicated software? Because you must know what is the most complicated software. Just like you know what is the tallest mountain, that is Everest, what is the deepest, right? Sea, what is the planet nearest to us, far further away. So what is the most complicated software? What type of software? Operating system. Windows, Linux, Mac, Android. So complicated. That is why only few operating systems in the world. So what is second to this? Second most complicated software is database management system. So that is why only few database management systems in the world. Seriously, just few data. Actually, there are lesser number of database management systems than operating systems. Actually, we have now large number of operating systems like Google Chrome, so many variations of Linux. But DBMSs, seriously, we have Oracle, Microsoft SQL, okay, MySQL. Those are the three major databases. Then small databases, those are not commercial databases like Access. Access are just like a toy for the kids. It's not a serious database. So the three serious databases are Oracle, Microsoft SQL, and MySQL. And there's variation of MySQL called MariaDB. So just three major databases. And now we have NoSQL databases like MongoDB. Because it's so complicated. Why? It is not just supporting SQL processing and so on. It must support transaction handling, security, backup and recovery, optimization, query optimization. Sometimes your database tables are in different machines in different in a network. Okay. So that is why I told you databases are the second most complicated software. Okay. So therefore, working with DBMS is also somewhat serious stuff. Right. So you can understand what is mean by file management. File management means ultimately your DBMS must write it to a file. When you write a SQL query to retrieve data, your DBMS need to access the file and data file and get it. Only thing is we don't worry about that. We just write SQL query like select all from employee. But when we send that SQL query, your DBMS need to open the relevant file, read the relevant data. So that is called file handling. When you do update, the DBMS need to open the file and do the changes to the record and again write it. And of course the query handling, because we are sending queries. We are sending SQL queries. So those queries must be understood by your DBMS, converted to some lower level code and execute it so that the files are open and done. Then security, backup and recovery. So you must be able to get backups, and from backups, you must be able to restore your database and transaction handling. So you can understand the file handling, query handling, security, and backup. At least you can sense it, right? Feed it. Maybe you don't understand perfectly, but you can sense what does it mean. But I know that a lot of you guys have a little bit doubts about what is transaction handling, right? What is transaction handling? Anyway, we are not serious about transaction handling, but it's good to know because that is also one of the major task of databases, especially if you study beyond A level, right? You become software developer. So what is mean by transaction? We are not going to cover these things because these things you get a feeling of it. I am going to give you a little bit of feeling of this, right? We are not going to discuss how to do transaction handling, but I want to give you the same sense as these things for this one also. So what is mean by transaction? Transaction එකක් කියන්නේ ගනුදෙනුවක්. For example, when you go for supermarket. So when you buy something, it's a transaction, right? So you pay money and you get the goods. Maybe you pay money, physical money, or you just pay by your credit card, right? It's a transaction, right? So all of you guys or your parents are paying the class fees, maybe online banking, or they go to the counter or they go to the ATM machine and deposit money. That is a transaction. So it's a two-step transaction. So money is deducted from your parents' account. Money is deducted, say 1,000 rupees. Then money is added to maybe my account. So it's a two-step process. Money deducted from one account, money added to another account. Maybe those two accounts are in the same bank or two different banks. It's a transaction. So transaction is set of activities. Set of activities. It's not just one activity, set of activities. And those set of activities must be either success as a whole or fail as a whole. So there can't be some halfway things. For example, money is reduced from your parents' account, but money is not added to my account. So that is not valid transaction because that is illegal. Because your bank has done illegal thing. Deduce money from one account and not take that money to the other account. So that is a dispute. If that happens technically, of course, bank will not do that purposely, but because of technical issues, maybe this is success, this is not success. So transaction handling means you must not get into this kind of partly success situations because that is illegal. That create disputes, obviously. Then that person will go and say that the bank, so you guys have reduced money from me, but it has not added to the other account. So transaction handling means when you have multi-step activity, either everything is done or nothing is done. So there's nothing called this is success and this is fail. If this failed, we must undo these things. Undo these things. Either everything is success or nothing is done. Nothing is done means if there's a failure in the middle, or previous step must be undone. So that is called committing a transaction or rollback a transaction. Okay, so that is also some major functionality DBMS support. Otherwise, database management systems will be useless. Okay, so this is just a gentle example to understand what is a transaction. Say transaction started, this happened in database. Say credit to account X, credit means adding money, and debit from account 1. So money added to this account, money reduced from this account. If both are success, we say commit, or database will commit it. Maybe this is success, but this is fail. Now it need to roll back. Roll back means undo this also, because otherwise it is invalid. So database management always make sure that either your transactions are committed or roll back. Okay. If there's failure in one step, roll back. If no failures, all steps are success, we say it's committed. If this is fail, this is undone, roll back. So that is called transaction handling. So therefore, when you do database subject, you must know what are the major functionalities of DBMSs. What are the major functionalities? File handling, query handling, security handling, backup and restore, transaction handling. Okay, transaction handling. So if you are not very sure, ask from ChatGPT or ask from, right? Maybe slightly different answer, but at least if I said 5 points, maybe ChatGPT mentioned 4 steps or maybe another additional 1 or 2. So what are the major functionalities? Or you can ask Google Gemini or any other AI agent you like. I personally prefer ChatGPT because it's so versatile. Major functionalities of a DBMS. Maybe just to make it simple, I will say in point forms. So you must be clever. Otherwise, this guy is going to give you a lot of details of DBMS in point forms. That means don't give me details. Right. So data storage, retrieval, update. That is number one, obviously, right? Save, update, delete. Data integrity management, right? Integrity, managing the integrity. You will learn about integrity management later. Data security, obviously. Concurrency control means related to transaction. Okay, related to transaction. So it's another name for transaction handling, backup and recovery. And you can see transaction handling, they have taken separately also. Actually, concurrency means when there are multiple users accessing the same data. I did not discuss that because it's advanced concept, but you can see backup and recovery, transaction management, security, data integrity management, and of course, obviously, data save, update, delete. And of course, I told you it's abstraction view of database is abstraction of your file. Rather than file view, it gives you upper level, easier to understand. And of course, the data dictionary. Now you can see that we have discussed all these things. So whether you go to UK or USA, right? Whether you go for an interview in a foreign company, so you must be confident that I know my subject because this is ICT. There's nothing called Sri Lankan ICT, right? Colombo ICT, Gampa ICT. No, ICT is ICT. It's a standard knowledge. So you must be an international level person, right? Live anywhere in the world, work anywhere in the world. Okay. And so many other things are also there, purposing, file optimizing, and so on. Okay. So have that confidence, okay? Have that confidence. Because in another 4-5 weeks, database will be over. Right. So now let's look at a bit of classification so that we can wind up this topic or discussion, introduction to databases. Because at the end of today's session, you must have the real confidence about the basic foundation about databases. Okay. Right. So bit of database types. Earlier we discussed evolution. Right. Historically, how databases move from network hierarchical databases to network databases to relational databases to object relational and object oriented, and even these days we have NoSQL databases. This is the current databases based on the type of use. Okay, right. So this is the classification we use: personal DBMSs, work group DBMSs, and enterprise DBMSs. Okay. So personal DBMS means you use it only one person. So that database instance is used by one person. That is what is my personal DBMS. So very good example is your address book in your smartphone. Right? So it's a database, very small, tiny database. But that database in your mobile phone is accessed by only you. So I'm not going to access your database in your smartphone. So if a database is only accessed by one person, it's a personal database. And those databases are super simple because not much complicated things for security, transaction handling, because just one person accesses it time to time. Okay, so that is called what? Personal database. Especially your smartphone or sometimes your laptop may have personal databases. Maybe contact management or your personal expense management, event management, like your scheduled tasks, to-do list, right? So sometimes you keep track of your tasks, your appointments. So your personal database is in your machine. Okay. Like Microsoft Access. That is the most popular personal database. Okay. So you use your Microsoft Access. I use my Access database. Then workgroup database means set of people access it, just few. Maybe someone in the project, someone in the class, maybe just 5-10 people access it. So that databases are a little bit more sophisticated because you need to handle security, a bit of transaction handling. but not millions of people access it like a banking database or database of something like Google Map, database of eBay. So these are just moderate databases, not very expensive, not very sophisticated, but you need bit of features now. Then we have the enterprise DBMS. That is your Oracle database, Microsoft SQL, MySQL. So we are thousands or sometimes 100,000, sometimes even millions of users access your database at the same time. So those are highly secure, high performing, optimized databases with a lot of concern, support for security, transaction handling. Right? So those are the databases we use in business context. Maybe hundreds of users, maybe thousands of users, even sometimes millions of users. Okay, serious databases. Personal DBMSs, workgroup DBMSs, enterprise DBMSs. Actually, this is how you subdivide software also, right? Personal software, workgroup software. Workgroup software is something like WhatsApp, Zoom. Then enterprise software like your inventory management system, order processing system. Right? Entire organization use it like a banking system. So the database is also the same classification. Personal DBMS, workgroup DBMS. That is personal software is maybe having a personal DBMS. Workgroup software may be having a workgroup DBMS. Enterprise software, you are having an enterprise DBMS like Oracle. Okay. Right. So finally, we will look at the different roles played by different people when it comes to databases. Right. So the database administrators are someone who take control of your databases or manage your databases. Right. So they install your database, configure your database, take backups, monitor the security performance. Right. So these guys are sort of a dedicated to the database handling. And even they can do the designing, right, development related things. So they are the technical people. Okay. Highly technical people. So they must aware of all three layers, especially the physical layer and logical layer, and bit of external layer. Right? So they are the administrating people. So therefore, they must definitely know about the physical layer, taking backups, security, optimization, right? DBAs. So then we have the database designers. Actually, our syllabus is more related to designer, right? More related to design. How to design it, how to understand the requirement related to data, model it, then design it, normalize it, optimize your design, then convert your design into database using SQL. So actually, rest of your syllabus is pretty much you think like a database designer, right? Prepare you as a database designer, and developer. Rest of the syllabus. So that is why you have the data analysis, data design, and development. Okay. And of course, the users. So users are not technical people. They just use, actually, they use the application. When they use the application, indirectly they use the database. Like you access, you look at your O-level results from the donext.lk site. So then you are an end user. But your results are coming from a database. So then you are playing the role of a user. Basically you are not, you don't need to worry about the tables, relationships, files, nothing. You are just interested about which URL, which query, right? Which report you want to access, right? Maybe a manager, supervisor, data entry operator, right? So what are the three roles? Administrator. So that guy must know all of these things because that guy take the control of that security, backup, and everything. Designer, they are pretty much interested in designing and development. Usually they don't involve in administration. And of course, the end users. End users are just the users. Okay. Right. Any questions? Any questions? Right. It's 6, exactly 6, and we are done. Okay. We are done. Okay. Right. So Now let's see whether we have done what is mentioned in your syllabus. So we start discussing topic 8, data versus information, structured versus unstructured data. We even discuss the semi-structured data, definition of database models like file-based, hierarchical, network, relational, object relational, right? And composition of database models like data dictionary versus data view, or the metadata versus data. Okay, so we have to look at all those things. Right? Distinguish data from information, of course, that we discussed in the very first day in AL-ICT. Define the database, list and briefly describe the database models, compare and contrast database models in terms of their features. Right. So the next class, we will move on to this particular topic, analysis of data, like ER diagrams. What is entity? What is a relationship? What is cardinality? Right. How to model ER diagrams. So that is our next topic. Then only we will go to designing, like what is a primary key, what is a foreign key, right? What is a candidate key, blah, blah, blah. And finally, we move on to SQL. Then also we will move on to the normalization, first normal form, second normal form, third normal form. Those are design related things. Okay. And finally, we will move on to SQL. Of course, your syllabus is here and there, but we will do it in a different manner. So first we'll do the introduction, then the analysis, then the design, then the development. So therefore, SQL will be your last topic. Though in your syllabus, SQL is, they have completely messed it by adding SQL to the top, but we will do it in a different way. So SQL will be our last topic. Okay, so next class, analysis and modeling the ER diagram, followed by designing, right? Primary key, foreign key, normalization. And finally, we will move on to SQL and finish your topic, database topic. Okay. Right. So we stop at this point, right? So today we don't do any past paper questions or whatever, because it's just the introduction only. Okay. Right. We stop at this point, right? Thank you.
Thank you, sir.
Okay. You're welcome.